Hi everyone, my name is Lim Chi-han. In this video, I'm going to present my final year research project. My research topic is the experimental and numerical studies on the behavior of polypropylene fiber reinforced concrete beam. Before I get into my presentation, let me talk about the overview first. There are basically 7 sections in this presentation. The first one is the introduction, second one is problem statement, and the third one is aim and objective, and followed by literature review, methodology, results and discussion, and lastly is the conclusion. Firstly is the introduction. Fiber concrete is a concrete containing fibrous materials which increases its structural integrity. The fiber concrete contains short discrete fibers that are uniformly distributed and randomly oriented. There is a wide range of fibers that can be used to improve toughness and mechanical properties of concrete. Also, the additions of fiber can help to reduce the plastic shrinkage cracking happen on the slab. And the fiber that I study for this research is the polypropylene fiber, which is shown in the picture on the right hand side. Next, the problem statement. The cracks on slab are likely to happen during the construction phase, which is the plastic shrinkage cracking. And also, the plant concrete normally contains numerous micro and macro cracks, and it will begin to propagate in the matrix when the loading is applied. In this research, there are basically 1 aim and 3 objectives. The aim of this research is to study the behavior of polypropylene fiber reinforced concrete beam through experimental and numerical studies. And the first objective is to validate and verify the elastic modulus of polypropylene fiber concrete from past research experimental results and formula. And the second objective is to determine the ultimate load carrying capacity and fractural strength of polypropylene fiber reinforced concrete beam through experimental study. And the third objective is to investigate the deformability of the polypropylene fiber reinforced concrete beam through finite element model. The literature review. Nakim, Salam, and Ahmed 2018 had conducted a study on evaluation of elastic modulus of fiber reinforced concrete. This past research determines the effect of discrete fibers on the elastic modulus of concrete and cement composites. Based on the results in this past research, fibers had very less effect on elastic modulus for fiber reinforced concrete with cost to fine aggregate ratio, which is C over S greater than 1. However, for the fiber reinforced concrete with C over S smaller than 1, the fibers will eventually reduce the elastic modulus. This is the formula for elastic modulus of fiber reinforced concrete. Based on the formula, if the value C over S is greater than 1, which means the cost to fine aggregate ratio is greater than 1, then the value for fiber effect factor will also equal to 1, which means the value of the elastic modulus will only depend on the compressive strength of the concrete. As the result, the higher the compressive strength of the concrete, the higher the elastic modulus of the fiber reinforced concrete. The methodology framework for this research basically can be divided into 3 parts. The first one is evaluation of elastic modulus, which is collecting the parameters from past researches and validate the selected parameters through finite element model ANSYS by comparing the experimental deformation and the analytical deformations. And the second part is the experimental study, which is conducting the experimental work, included sheathing, concrete casting, and curing, and also conducting the testing such as compressive strength test and fractural strength test. And the last part is the numerical study. The numerical study is calculating the modulus of elasticity by using the formula that I mentioned in the literature review. And after that, model the deformations of polypropylene fiber reinforced concrete beam through finite element model ANSYS. Now move on to the results and discussion. The first one is the evaluation of elastic modulus. The two graphs shown at the right hand side are the comparison of deformation between the experimental results and the analytical results. Look at the graph. The blue color one is the experimental results, and the green color one is the formula. And the graph below is also the same. And based on the graph, the modulus of elasticity obtained by the formula has the highest correlation coefficient, which is up to 94.19%, and therefore it is adopted for numerical study, which is modeling the deformation of polypropylene fiber reinforced concrete beam that has been tested in the experimental study. Then is the experimental study results. The compressive strength of polypropylene fiber concrete with fiber content of 1% and 2% increased by 3.81% and 20.63% in comparison to the value obtained for normal concrete. As we can see from the graph, the 2% of polypropylene fiber content has the highest compressive strength. However, the compressive strength of 3% polypropylene fiber concrete dropped 3.26% compared to the normal concrete. The flexural strength. The addition of polypropylene fiber is actually increasing the flexural strength of the concrete beam. Based on the graph, the flexural strength of the beam increased by 0.15%, 6.97%, and 1.62% with addition of 1%, 2%, and 3% of polypropylene fiber content respectively. Look at the graph. The concrete beam with the polypropylene fiber content of 2% dosage will have the highest flexural strength, which is 26.359 megapascal. Now move on to the failure patterns of the beams. Look at the picture at the left top corner, which is the concrete beam with 0% of polypropylene fiber, and the picture below that is the concrete beam with 3% of polypropylene fiber content. The crack formations were marked on the spot when there was any crack occur on the beam. And based on the failure pattern of the beams, it is found that more minor cracks were formed for the beam with higher percentage of polypropylene fiber. Besides, it is noticed that the cracks were distributed wider for the beam with 3% of polypropylene fiber content compared to the beam with 0% of polypropylene fiber content. Next is the numerical study results. The deformation results in numerical study were obtained through finite element model ANSYS, and based on the graph, the 2% of polypropylene fiber reinforced concrete beam has the highest ultimate load carrying capacity. And also, the 2% polypropylene fiber reinforced concrete beam has the smallest maximum deformation compared to the other. Based on the work presented in this study, the conclusion can be summarized as follows. The formula of EC equal to 4,700 multiply lambda VF and multiply the square root of compressive strength can be used to calculate the elastic modulus of polypropylene fiber reinforced concrete, which is validated through the analysis. And the addition of polypropylene fiber up to 2% could increase the compressive strength of the concrete. And also, the additions of polypropylene fiber in the reinforced concrete beam could increase its fractural strength and the ultimate load carrying capacity. And lastly, the ductility characteristics of concrete beam have improved with the additions of polypropylene fiber. And this is the reference that I have used in these presentations. That's all for my presentation, and thank you for your listening.